So what this question is saying is there is an inclined plane, okay, with angle alpha. The length out here is given as 2.10 meter. Okay, and this block is sliding down. Find the value of alpha so that this block takes minimum time to slide down. Now some of you might have the intuition, so let's make this alpha 90. If I make this alpha is 90, this becomes flat and this block will fall down with mg, which has the highest acceleration. Okay, you can do that, but in this question, what is fixed? This length is fixed. Okay, that means whatever is the length of this inclined plane, this length into cos alpha is equals to L, and this L is fixed. That means as soon as you increase the value of alpha, what will happen? The length of this inclined plane would increase. See, because you have to somehow make the this much distance is equals to L, or you somehow have to make the horizontal distance is equals to L. Okay, and this length can be variable, and this length is varies according to alpha. Understood? So if I make this alpha is equals to 90°, the length of this inclined plane would be infinity. Okay, understood? So what happens if I make this alpha 0°? Okay, the length of this inclined plane would be equals to L, but that time the driving force would be equals to 0. Why? Mg sine into 0 is equals to 0. So there will be no acceleration that would be pushing this block towards this side. Okay, so if alpha is equals to 90, it would have the highest acceleration, but the length it would have to travel is equals to infinite. Okay, if alpha is equals to 0, it would have L distance to cover. Okay, but the acceleration to drive towards that L is equals to 0. So somewhere between L is alpha is equals to 0 and alpha is equals to 90, there is some value of alpha for which the time taken for this block to reach this distance would be minimum. And how do I find out that? So you somehow got the idea that you have to do differentiation. Okay, differentiation and make it is equals to 0. But what are the parameters of differentiation? Let's draw the free body diagram of the block. In the free body diagram of the block, the acceleration is Acha. Is there any friction force out here? Yes, friction force is there. Okay. So forward force is mg sine alpha. The retarding force is how much? Mu mg cos alpha. And the acceleration is a. Okay, but the mass is m. So mg sine alpha minus mu mg cos alpha is equals to ma, or a is equals to g sine alpha minus g cos alpha, or g into sine alpha minus mu cos alpha is equals to a. So this is our first equation. So the acceleration of the block would be equals to how much? G sine alpha minus mu cos alpha, where alpha is the angle of the inclined plane and mu is the coefficient of friction that is given out here. Okay, now the block is sliding from this position to this position. Okay, so we have to apply S is equals to ut plus half at square. S is equals to ut plus half at square. The initial velocity of the block is equals to 0. See, the block is start sliding. Start sliding means initial velocity is equals to 0. U is equals to 0. Okay, the value of acceleration is nothing but this value. The value of acceleration is g sine alpha minus mu cos alpha. Okay, out here the value of s, or the value of distance s, is how much? S is nothing but the distance it has to cover for the entire distance. Okay, can I say s cos alpha is equals to L? S cos alpha is equals to L. Okay, or S is equals to L by cos alpha. So S out here is nothing but L by cos alpha. So when we rewrite this equation, what happens? L by cos alpha is equals to half g sin alpha minus mu cos alpha t square. Okay, so to isolate the time t, why? Because you are solving for time, you have to minimize the time t square. T square is equals to, I have to take this entire term to the left hand side, leaving behind the t. So L by cos alpha into 2 by g, 2 by g sin alpha minus mu cos alpha is the value of t square. So the value of t is nothing but under root of this. So we found out the equation of time. We find out the equation of time, where time is equals to L 2L by cos alpha g into sin alpha minus mu cos alpha. Now in this equation, what are constants and what are variable? Yes, this 2 is constant, this L is constant, this G is also constant, acceleration due to gravity. Out here alpha is equals to variable, no? So can I rewrite this equation as T is equals to 2L by G into cos alpha into sin alpha minus mu cos alpha. Okay. Yeah. Can I say T will be minimum when this value is maximum? See, you cannot change this value. 2L by G you cannot change. Okay, you can only change this value. So can I say T will be minimum when this denominator is maximum? So I have to max out the value of cos alpha into sin minus mu cos alpha. Okay. Now you have to maximize this value. Okay, this value. So out here cos alpha sin alpha minus mu cos square alpha minus mu cos square alpha. You have to maximize this value. Okay, what is the maximum of this value? So whenever you have to find out maximum, just differentiate it and make it equals to 0. So d of this function by d alpha is equals to 0. So you get the maximum value of this function. We can also get the minimum value of this function, but since this is physics, we won't go into the details of monotonicity. Okay. Okay, out here cos alpha sin alpha, cos alpha sin alpha, I can multiply this by 2, divide this by 2. 2 cos alpha sin alpha is nothing but sin 2 alpha divided by 2. Okay, so out here this is nothing but d into sin 2 alpha divided by 2 minus mu cos square alpha, okay, by d alpha should be equals to 0. Okay, out here if I differentiate this, what will come? When I differentiate this entire equation, what comes out? Sin 2 alpha, differentiation of sin 2 alpha is cos 2 alpha into 2 divided by 2 minus differentiation of this one term is nothing but mu into 2 cos alpha, okay, into sin alpha or minus sin alpha. Differentiation of this term is nothing but minus 2 into cos alpha sin alpha, which should be equals to 0. Which should be equals to 0. So out here 2 and 2 gets cancelled. So let's erase this one. Okay. Can I take this cos 2 alpha to the right hand side? Of course. So out here it would be minus of cos 2 alpha. Okay. 2 cos alpha and sin alpha. 2 cos alpha sin alpha. 2 cos alpha sin alpha is nothing but sin 2 alpha. So 2 cos alpha sin alpha is nothing but sin 2 alpha. Or out here Sin alpha by cos alpha is equals to minus 1 by mu, or sin 2 alpha by cos 2 alpha is equals to minus 1 by mu, or tan 2 alpha is equals to minus 1 by mu. Okay. If you put the value of mu is equals to 0.140, okay, and use calculator, the value of 2 alpha would come out to be 98. 2 alpha is equals to 98, or alpha is equals to 98 divided by 2 is equals to 49 degree. So for alpha is equals to 49 degree, okay, it would take minimum time to travel this much distance. Okay, this length is not fixed. This length is fixed, and this length can vary according to this length or according to alpha and this length. Now the second part of the question is, what is the time equal to? The equation of time is already given as this one. So out here, if you put the value of L as 2.1, G as 10, cos alpha as cos 49 into sin 49 minus mu cos 49. So we get the value of time to be nearly in this equation. Okay, we have to put down all the variables, and alpha is equals to 49 degree for minimum time. We get the time nearly equals to 1 second. 1 second. In this question, what is happening is there is a block kept out here. Okay, this is kept on an inclined plane with angle alpha, and this block is being pulled by a rope of tension T. Out here, this is tension T. Okay, now the question is saying find out the value of beta so that this T is minimum, or the tension of the rope is minimum for this block just to start sliding. Just to start sliding means out here acceleration is nearly equals to 0, but out here acceleration will be in this direction. 0, see, although 0 has no direction, this is 0.00001, but the acceleration will be on this direction. What the question is trying to say is that the friction force will be along this direction. Okay, so let's draw the free body diagram of the body. Whenever there is an inclined plane, we always take component along the inclined plane and perpendicular to the inclined plane. So along this component, this is T cos beta, out here is T sin beta, out here is mg cos alpha, out here is mg sin alpha, and there is a normal reaction force exerted by the inclined plane on the block, and there is a normal reaction force. Okay, and the friction force will act along this direction, and there is also a friction force that acts opposite to the direction of motion. Friction force. Okay, let's draw the friction force. Let it neat and clean. This is friction force. Okay, and the block is accelerating in this direction with nearly equals to 0. Okay, so our first question is first, what is the value of n? So from perpendicular component, okay, so from perpendicular component to the inclined plane, we get T sin beta, T sin beta plus n is equals to mg cos alpha, mg cos alpha, because there is no acceleration along this direction or perpendicular to the incline, or n is equals to mg cos alpha, okay, minus t sin beta, minus t sin beta. And what is the value of friction force? The value of friction force is nothing but mu into n. The value of friction force is equals to mu into n, or is equals to mu into, what is the value of n? Mg cos alpha minus t sin beta. Okay, now let us take component along the axis, that is towards the or along the inclined plane. So along the inclined plane, okay, what is the component? If you write down the equation, I'm writing down the equation along the inclined plane. What do I get? T cos beta minus mg sin alpha minus friction force. What is the value of friction force? Minus mu mg cos alpha minus t sine beta is equals to m into acceleration, where acceleration is nearly equals to 0, is equals to 0. Okay, because mass into acceleration is equals to 0. Why? Because acceleration is nearly equals to 0. So let's make this neat and clean. So out here, t, I have to isolate the value of t. Why? Because I have to take t minimum. I have to make the value of t minimum by adjusting the value of beta. I cannot adjust the value of alpha. I can only adjust the value of beta out here. So out here, let's isolate the value of t. So t cos beta, this is done, minus or plus mu t sin beta, this is done. Okay, minus mg sin alpha, this is done, minus mu mg cos alpha, this also done, is equals to 0. Okay, so out here, can I take this entire term to the right hand side? If I take this entire two terms to the right hand side, what do I get? Is equals to mg sin alpha plus mu mg cos alpha. Okay, I took this entire term to the right hand side, this two term to the right hand side. Now can I take 2t common out here? So if I take t common out here, t into cos beta into mu sin beta. Can I take mg common out here? Okay, so out here I'm taking mg common, mg, so mg common out here. Okay, so out here t is equals to mg sin alpha plus mu cos alpha divided by how much? Cos beta plus mu sin beta. Now I have to make the value of t minimum in this equation. So in this equation, what are constant, what are variable? Mass into g. Out here, mass is equals to constant. Why? You cannot change the mass. G is equals to constant. Mass is equals to constant. G is equals to constant. Okay. Out here, sine alpha. Can the value of alpha in this inclined plane change in the question? No, I can only vary the value of beta. So out here, alpha is also equals to constant. So this value is also equals to constant. Can I change the value of mu, coefficient of friction? No, because k is also constant. But I can change the value of beta, which is variable, cos beta, which is variable. So get the minimum value of t. Okay, to get the minimum value of t, this cos beta plus mu sin beta should be maximum. Understood? So maximum value of cos beta plus mu sin beta. Okay, so to find the maximum value of cos beta plus mu sin beta, so d of cos beta plus mu sin beta by db is equals to 0. Whenever you have to find out the maximum or minimum in physics, always differentiate and make it equals to 0. Or minus of sin beta plus mu cos beta is equals to 0. Okay, so if we do it, or tan beta is equals to mu. Okay, so the minimum value of beta would be, or the maximum value of this equation would be, for beta is equals to how much? Tan beta is equals to, what is the value of mu? Coefficient of friction is equals to k. Okay, if tan beta is equals to k, okay, what is cos beta plus k sin beta? So out here in this equation, let's draw a right angle triangle where this is beta. Tan beta is equals to k. That means perpendicular by base is equals to k. Okay, what is hypotenuse? Hypotenuse is nothing but k square plus 1 square. Okay, I just draw a right angle triangle with angle beta. If tan beta is equals to k, so perpendicular by base is equals to k, or perpendicular by 1 is equals to tan beta. Okay, so from this triangle, what is the value of sine beta? From this triangle, the value of sine beta is equals to k by k square plus 1. Okay, acha. What is the value of mu sine beta? Sine beta is k by k square plus 1. So into k. So k square by k under root of k plus 1. K square by under root of k square plus 1. This is the value of mu sine beta. What is the value of cos beta from this diagram? Cos beta is nothing but 1 base by hypotenuse k square plus 1. So out here cos beta is nothing but 1 divided by under root of k square plus 1. So out here the value of or maximum value of cos beta plus mu sin beta is nothing but 1 plus k square. 1 plus k square can also be written as k square plus 1 by under root of k square plus 1. See, the LCM is same, so you can add this both, no, taking the same LCM of k square plus 1 by k square plus 1. See, out here k square plus 1 can be written as under root of k square plus 1 whole square. Okay, so this whole square and this whole square will get cancelled, or the maximum value of cos beta plus mu sin beta would be under root of k square plus 1. Okay, so if you put k square plus 1 out here, okay, the value of tension would be equals to, okay, mg sin alpha minus mu cos alpha by what is the maximum value of cos beta plus mu sin beta? Under root of k square plus 1. Under root of k square plus 1. Understood the question? So what the question is saying is that there is a block and this being pulled up by force F, and this alpha is constant. That means the direction of force is making an angle alpha with the horizontal. Okay. The first part of the question is asking the velocity at the moment breaking off of the plane. That means when this block slides off of the plane or starts going off of the plane. So that happens when the normal reaction force becomes zero. Okay, these blocks breaks off this plane when the normal reaction force out here is equals to zero. So out here, if you draw the free body diagram of this block here, the normal reaction force is out here. Okay, F will be component into F cos alpha and F sin alpha, and downward there will be a gravity force of mg. Okay, and is there any friction force out here? Smooth horizontal plane, so the coefficient of friction is equals to 0. There is no friction force. Okay, or mu is equals to 0 instead of k. See, while I write mu in most of the cases, irodov takes mu as k. Okay, the velocity of the body at moment of its breaking off. See this f. F has a value of at. That means it is increasing with respect to time. So at, and out here also at. So when it will break off, when n becomes 0. So at sin alpha plus n minus mg is equals to mass into acceleration. So the moment of breaking off, what will happen? This acceleration will be upward, and the acceleration will have a value of 0.00001, which is approximately equals to 0. Mass into acceleration, which will be very less. And at the moment of breaking off, what will happen? The value of normal contact forces will also be 0. Okay, so out here at sin alpha minus mg is equals to 0, or at sin alpha is equals to mg. Okay, or t is equals to, for solve this equation, t is equals to mg by a sin alpha. So when time t is equals to mg by a sin alpha, this block will break off from the ground. Now the question is asking find the velocity of the body at the moment. Okay, so out here, this body will have a horizontal force, and this horizontal force will cause a horizontal acceleration. So horizontal acceleration is how much? Horizontal acceleration, okay, let's take acceleration as AC or AH as horizontal acceleration. If I draw the horizontal component of force, AT cos alpha is equals to mass into AH, or horizontal acceleration is equals to AT cos alpha by mass of the block is equals to AH. This A out here is the constant in the question. Okay, this is not nothing to do with acceleration. This A out here is the horizontal component of acceleration. Okay, now see the acceleration is also varying with respect to time. Okay, so how do I find out the velocity? Okay, when the body breaks contact. See, okay, can I say dv by dt is equals to 0? Sorry, dv by dt is equals to acceleration. Okay, so total rate of change of total velocity is equals to total acceleration. Does it have any vertical component of acceleration till the moment of breaking off? No, it only has horizontal component of acceleration. So if I integrate this, dv by dt is equals to, what is the value of acceleration? The value of acceleration is nothing but at. Okay, at cos alpha by m. What is variable out here? T. So if I integrate this, dv is equals to at cos alpha by m into dt. Okay, when I integrate this value, I get v is equals to, let me integrate this value out here. Okay, or v is equals to a cos alpha by m into t square by 2 plus some constant, plus some constant. Okay, let me put the boundary condition. At moment t is equals to 0, f is equals to 80. Okay, so what is the initial velocity? See, body of mass m resting on a smooth horizontal plane. That means this part of the question is saying that the initial velocity is equals to 0. Okay, so when t is equals to 0, my boundary condition out here would be, when t is equals to 0, v is equals to 0. So if I put t is equals to 0 and v is equals to 0 in this equation, what do I get? I get the constant is equals to 0. See, put the values. So my main equation of velocity becomes v is equals to a cos alpha by m into t square by 2. Okay, now I need to find out the velocity of the body when the moment of its breaking off. That means at the time when it was breaking off. And what was the time when it was breaking off? The time was mg by a sine alpha. So if I substitute mg by a sine alpha out here, I'll get the velocity. So velocity at the time of breaking off was v is equals to a cos alpha by m. And what was the time while breaking off? T square, or mg by a sine alpha square divided by 2 divided by divided by 2. Okay, if I solve this, this becomes m g square cos alpha by 2a sine square alpha, or velocity out here was equals to mg square cos alpha by 2a sine square alpha, cos alpha by 2a sine square alpha. Now let's read the second part of the question. The second part of the question is the distance traveled by the body up till this moment. Okay, so what is the distance traveled by the body? The distance is only traveling in x direction. There is no y component of acceleration or velocity, no. So the distance traveled is nothing but, what is the equation of velocity? Equation of velocity is this one. So can I x dx by dt is equals to velocity? So I'll do this on the next page. So the equation of velocity is this one. That means the velocity keeps on changing as we go towards x. So I can simply use dx by dt is equals to v. Okay, but v is equals to dx by dt. I'll take the equation of v from here and substitute out here, or is equals to a cos alpha by m into t square by 2. Or if I solve this equation, x is equals to a cos alpha by 2m into t cube by 3 plus some constant. Okay, so whenever there is indefinite integral, we put up a boundary condition, and out here the boundary condition is at t is equals to 0, x is equals to 0. Why? Because the body mass is starting from rest and you have to find out the total distance travel, no? So at time t is equals to 0, distance travel t is equals to 0. Okay, so if you put t is equals to 0, x equals to 0 out here, we get the value of constant is equals to 0 out here. So the value of constant is equals to 0, or x is equals to a cos alpha by 2m t cube by 3. Okay, and when does the velocity, means at what time does the body break off? Okay, this moment means nothing but the time till which it break off, which is t is equals to mg by a sin alpha. Okay, so if I put the value of mg by a sin alpha out here, I get the total distance. So x is equals to a cos alpha by 2m into 3 into t cube, which is mg by a sin alpha cube. When I solve this, I get the value of is nothing but m square g cube cos alpha by 6 a square sin cube alpha. So this was our problem out here. Now out here what the question is saying is that there is a block that is kept on smooth ground. Okay, there is a force acting making an angle alpha with the horizontal, but right now this alpha is not constant. Okay, this alpha varies with the distance it travels. Suppose at t is equals to 0 the block was out here, at t is equals to 1 second or 2 seconds the block valid or block travel this much distance. So alpha would be nothing but some constant into the distance. So initially the force was in this direction. As the body keeps moving in this direction, what happens? The angle of force rises upwards, or this force vector becomes in this direction. Okay, so out here alpha is equals to a into s. Okay, out here alpha is not constant. Now the question is saying find the velocity as a function of alpha. Okay, so out here in order to find out the velocity, I need to find out the acceleration. There is a horizontal component of acceleration. Okay, and until and unless the vertical component of force becomes greater than mg, there will be no vertical component of acceleration. So initially when the force was in this direction, there was no vertical component of acceleration. Okay, so I'm assuming all my acceleration or all my movement happens in the horizontal direction. Understood? So if cos alpha is equals to how much? Mass into horizontal component of acceleration, or if cos as is equals to mass into horizontal component of acceleration. Okay, now how can acceleration be written as? Acceleration can also be written as v dv by ds, where s is the distance traveled, Understood? So if I write this equation as if cos as is equals to m into v dv by ds. Okay, so out here ds is there, out here as is there, we somehow have to integrate it. So let's take constant to one hand side and the variables to the other hand side. Out here f is also mg by 3, mg by 3. Okay, so let's solve this one. Cos as into ds is equals to m into 3 by mg into vdv. vdv. M and M will get cancelled. Okay. So if I solve this one, I'll get nothing but d by g vdv. Integration of cos as ds. This will be nothing but sin as by a, okay, is equals to 3 by g into v square by 2, the integration of this one, okay, plus some constant. Now I have to put a boundary condition to solve for this constant. Okay, what are the boundary conditions? See out here. Resting means at, what does resting mean? Resting means initial velocity is equals to 0. So at t is equals to 0, s is equals to 0, because at t is equals to 0, the block will move nothing, no? So s at t is equals to 0, s is equals to 0, and v is also equals to 0. Why? Because the block was initially at resting. So boundary condition is t is equals to 0, s is equals to 0, v is equals to 0. Now put the value of s is equals to 0 out here and v is equals to 0 out here. When you put those values, you get the value of constant is equals to 0. Okay, or our equation of velocity becomes sin as by a is equals to 3 by g v square by 2. Or if I send the entire thing to the right hand side, this 3 by 2g goes to the left hand side and becomes 2g by 3. So it is nothing but 2g by 3. Okay, so v square is equals to 2g by 3. I'm writing v square out here. If I put v, so if I remove the square, it would be v is equals to under root of 2g by 3 sin as by a. So this is the velocity as a function of s. Okay, where as is equals to alpha. So in this question, what the question is trying to say is that there is a ground. Okay, there is a motor of mass m. That means inside this box, a motor of mass m is kept, and this motor is wound up by a string. Okay, there is a rope wound out in this motor, and that rope is connected to a block of mass 2m. 2m. Okay, this is the connection. Okay. The coefficient of friction between the ground and this slab is k. The coefficient of friction between the ground and this motor is k. That means the ground has a friction coefficient of k. Okay. Now the question is asking, as soon as I start the motor, this motor will start spinning. So what will happen? This rope will try to pull this 2m block towards itself. Okay. The question is saying, if the distance between the blocks are L, okay, how soon will they collide? How soon will they collide? That means find the time. Find time for collision. Find time required for collision. So time required for collision. This is our question. Okay. Now in the question, okay, this 2m is being pulled up by tension. So let's draw the free body diagram. Free body diagram of 2m is being pulled by tension. It is being opposed by friction, which is equals to 2m kg or k 2mg. Okay, and has acceleration of a, say a of block, a of block. So out here, see, while dealing with uh, Newtonian mechanics or while dealing with vectors, always assign the coordinate system. I'm taking this side as positive, this side as negative, upward as positive, downward as negative. So out here, if I write the equation out here, what will be the equation? T minus k into 2mg or 2mg k minus 2 mgk is equals to 2 ma. This is our first equation. Now let's draw the free body diagram of the motor. Motor has a mass m. The tension is pulling it this side. Okay, because the ropes are same, the tension in the rope will be same. So out here it is T, which is moving away from the body, and this is T, moving away from the body. Tension force always moves away from the body. Okay, and the opposing force of friction force, which is equals to K into mg. Okay, and this is moving in this direction with acceleration of motor. So how do I write the equation? Minus T plus kmg is equals to m into minus am. Why minus am? See, this direction is minus, this direction is plus. Okay, so out here if I modify the equation, minus T plus kmg is equals to minus m into am. This is equation number 2. Now when you solve equation 1 and 2, what do you get? See, if I write my equation out here 1 and 2, so minus T plus kmg or mgk, both will have the same significance, plus mgk is equals to minus m into acceleration of motor, whereas this was the acceleration of block. The equation number 2. I wrote the same equation out here. Okay, now let's solve this two equation. Plus t minus t gets cancelled, so it would be minus mgk is equals to m into 2 acceleration of block minus acceleration of motor. Okay, or if I multiply left hand side by minus 1 and right hand side by minus 1, what do I get? mgk is equals to mass into acceleration of motor minus acceleration of minus twice of acceleration of block. Twice of acceleration of block. Okay, I can cancel out the mm. So gk is equals to acceleration of motor minus twice of acceleration of block. So I'm writing this neatly. Acceleration of motor minus twice of acceleration of block. Okay, so out here, this is the relation between acceleration of motor and acceleration of block. Now the question is saying what is the time taken for this block and for this block to collide. So whenever collision occurs, okay, we'll change our frame of reference from ground. See, this acceleration and this acceleration of motor was from ground reference, okay. So if I want to say collision occurred, that means what? I have to put my observer either in this block or in this block and observe the other body coming towards me, and the collision will occur when the other bodies covers a distance of L. See, from ground reference, this is covering some much, this is covering some much distance. Okay, but it is very difficult to calculate from ground frame of reference. See, if I take this frame of reference, okay, and I say acceleration of motor with respect to, this is nothing but acceleration of motor with respect to block. Okay, so what is the relative distance? L. What is the initial relative velocity? 0. What is the initial relative acceleration? This. Okay, and what is the distance it has to cover? L. Understood? So now I have to find out relative acceleration of motor with respect to block. You can also put your observer on motor and find out the relative acceleration of block with respect to motor. Okay, it doesn't make a difference. So let's put our frame of reference in. It doesn't make a difference. You can either do this also. Okay, and out here acceleration of block with respect to motor. So after to find out acceleration of block with respect to motor is equals to acceleration of block minus acceleration of motor. Okay, what is acceleration of block? Let the acceleration of block be AB. Okay, now see, acceleration of motor in terms of acceleration of block can be given out by this diagram. Okay, so acceleration of block is nothing but gk or acceleration of motor is nothing but gk minus 2ab is equals to, or gk plus 2ab is equals to acceleration of motor. I just send this plus 2ab to the left hand side. So acceleration of motor is nothing but gk plus 2 into acceleration of block. So acceleration of motor is nothing but gk plus 2 acceleration of block. Okay, now if I add this one, acceleration of block with respect to motor is nothing but acceleration of block plus 2 acceleration of block is equals to 3 acceleration of block. 3 acceleration of block. Okay, plus g into k. Understood? So the time required for collision. Okay, you can simply apply AC is equals to ut plus half at square. Q initial velocity was 0. Okay, because the blocks were initially at rest. Distance covered with respect to this frame or with respect to any frame is equals to L. Distance that must be covered is equals to L. Out here acceleration is nothing but 3 into acceleration of B plus gk. Okay, and out here, so if you solve this one, L is equals to half 3 acceleration of block plus gk into t square, or 2L by 3 into acceleration of block plus gk is equals to t square, or t is equals to, or time taken is equals to under root of twice of L divided by 3 into acceleration of block plus gk. Understood? What the question is saying is that there is a lift. It means elevator. Okay. Inside this elevator, there is a pulley system of block mass m1 and m2. Okay, and this lift is moving up with acceleration omega naught. Okay, now the question is saying find the acceleration of m1 and m2 relative to the lift. That means when our frame of reference is in the lift, and relative to the elevator shaft. That means relative to the ground. Elevator shaft is nothing but the frame holding the elevator. So the frame holding the elevator is same thing as frame holding the ground. Okay, so find the relative velocity of m1, sorry, relative acceleration of m1 and m2 with respect to the lift and with respect to ground. The second part of the question is find the force exerted on this rope, or find the tension force exerted on this rope holding the two pieces. Okay, so we'll take our frame of reference to the lift. Why do I take up my frame of reference to the lift? Because the relative acceleration between m1 and m2 becomes relatively simple out here. See, if I take my frame of reference in the lift, assuming m1 is greater than m2, assuming m1 is greater than m2, you can also assume m2 greater than m1. It will have the same effect on the result. So acceleration of m1 will be downward. Okay, the relative acceleration of m2 would be upward. See, if you take the frame ground of frame, no, okay, out here if you take A, out here it would be different than A, okay, from the frame of reference of ground, because both are moving up with omega naught also, no. Understood? So it's much easier to solve from frame of reference of the lift. So from the frame of reference of CCTV, I'm drawing the free body diagram from CCTV. Okay, the observer on CCTV is drawing the diagram or free body diagram of these blocks. So m1 is moving down with acceleration a, t is upward, m1g is downward. Am I missing something out here? Yes, pseudo force. See, the acceleration, the frame of reference or the observer itself has an acceleration of omega naught. So whenever an observer has an acceleration, we call them non-inertial frame. So if the observer has an acceleration, any object that he looks into will have a pseudo force, and the magnitude of pseudo force is nothing but mass of the block into acceleration of the observer. Mass of the block into acceleration of the observer. And the direction of pseudo force is directly opposite to the direction of acceleration of observer. Understood? So this was the entire concept out here. Okay. Similarly, if I draw the free body diagram of M2 out here T, then uh, the acceleration is A. Okay. Out here M2G and out here M2 omega naught. M2 omega naught. Now for this setup, if I drop upward to be positive, downward to be negative, right positive, left negative. If I draw the equation out here, so T minus M1G minus M1 omega naught is equals to M1 into minus A or minus M1A. Okay, if I multiply the entire equation, if I multiply the left hand side by -1 and right hand side by -1, what do I get? M1G plus M1 omega naught minus T is equals to M1A. Okay, these two equations are the same thing. Okay, now if I write the second part of the equation, if I write the equation of this body, what do I get? T minus M2G minus M2 omega naught is equals to M2A. Now this is our equation 1, this is our equation 2. If I solve equation 1 and 2, what do I get? Let's solve equation. I'm writing both the equations side by side out here. Okay, so M1G. So I wrote both my equations side by side over here. This is the first equation and this out here is the second equation. If I try to solve it, if I add equation 1 to equation, what do I get? T and Q would get cancelled. So M1 minus M2 into G, M1 minus M2 into G plus M1 minus M2 into omega naught is equals to M1 plus M2 into A. Okay, if I take M1 minus M2 common, M1 minus M2 is equals to G plus omega naught is equals to M1 plus M2 into A. Can I send this M1 plus M2 to the left hand side? Of course. So divided by M1 plus M2 divided by M1 plus M2. M1 plus M2 out here A. So A is equals to this value. Okay. This value of A comes from which frame of reference? That means from which observer is the acceleration this value? From the observer that is on the CCTV. Okay. Now I need to apply the acceleration or find the acceleration from ground. From ground. Okay. So from ground, okay, whatever is the value of A, okay, see out here, the acceleration of M2 would be A plus omega naught, okay, because omega naught is already moving up and A is moving up inside the frame. So the relative acceleration of M2 would be A plus omega naught, whereas the relative acceleration of M1 would be omega naught minus A. Why? Because omega naught is trying to move it up and A is trying to move it down. So relative acceleration of M2 with respect to ground is equals to how much? A plus omega naught. Okay, but A has the value of this one, and relative acceleration of M1 with respect to ground is nothing but omega naught minus G. Sorry, minus A, not G, minus A. Okay, why? Because out here A is trying to move up, omega naught is trying to move up, A is trying to move down. Out here, why not A minus omega naught? See out here, upward is positive, downward is negative. So plus omega naught minus a. Out here both are positive. So plus a plus omega naught. Understood the question? Okay. Now put the value of a out here. Put the value of a out here and solve the question. Okay. So first part of the question is being solved. Now we get the second part of the question. The force exerted by the pulley on the ceiling of the car. That means what is the tension force on this rope? Okay. So the second part of the question was find the tension out here. Okay. So can I say in this diagram, if the tension is T out here, the tension is T out here, this pulley with this one is exerting a tension of T and tension of T. Okay, out here and out here from the free body diagram of pulley. This is tension T, this is tension T. And is the pulley moving anywhere with respect to this frame? No. So the pulley has an acceleration of 0. If I apply common sense, that means let the upward force be x. Say I can simply say that x is equals to 2t. If I draw the free body diagram of the pulley and draw out all the force acting on the pulley, which is t downward, t downward, t downward, t downward. Okay, the acceleration of the pulley related to this frame is 0. So there must be an upward force in this frame only. Okay, that is pulling the pulley upward. Okay, there is also a pseudo force acting on the pulley, but unfortunately the mass of the pulley is 0. So 0 into whatever is the pseudo force. So pseudo force will always be 0. Okay, so out here the force on the rope is equals to 2t. Okay, or force on this rope is equals to 2. This much I have established. Now how do I find out the value of t? See, you can take hold of any equation, either this one or this one. Okay, let me take this one, or let me take the equation in terms of m2. So I can easily say t minus m2g, m2 I'm taking common into g plus omega naught. G plus omega naught is equals to m2 into a. I've already found out the sorry, I've already found out the acceleration of the block m2 relative to the CCTV. Okay. So out here we substitute the value of a by how much? m1 minus m2. Okay. You get the gist. You have to substitute the value of acceleration by this value. Okay. So t is equals to m2a plus m2g plus omega naught. Okay, if I take m2 common, t is equals to m2 into a plus g plus omega naught. Okay, now I'm solving out here. T is equals to m2 into what is the value of a? m1 minus m2 by m2 g plus omega naught, g plus omega naught divided by m1 plus m2, m1 plus m2. Okay, plus g plus omega naught, plus g plus omega naught. Okay, now out here, if I solve this one, okay, it would be nothing but, okay, now can I take this entire thing as an entity? So t is equals to m2 into m1 minus m2 into g plus omega naught plus I'm taking LCM as m1 plus m2, m1 plus m2. So out here g plus omega naught will be multiplied by m1 plus m2. Okay, okay. Out here, can I take g plus omega naught common from both? So t is equals to how much? T is equals to, let me erase this one. Okay, this is just equation solving. So t is equals to m2 into g plus omega naught, g plus omega naught, okay, into m1 minus m2, m1 minus m2 plus m1 plus m2 plus m1 plus m2. Okay, see, g plus omega not common from both, then m1 minus m2 plus m1 plus m2. Okay, divided by m1 plus m2, divided by m1 plus m2. Okay, so out here minus m2 and plus m2 would get cancelled. Okay, and m1 and m1 would get 2m1. So this entire thing would get replaced by 2m1, 2m1. Okay, understood this much? So again, if I solve this one, p is equals to, okay, 2m1 m2 by m1 plus m2 into g plus omega naught. Okay, now out here, what is the force out here? The force out here is 2t, not t. So I have to multiply this entire term by 2. So x is equals to 2t is equals to 4 into m1 m2 by m1 plus m2 into g plus omega naught. Okay, see, one more thing. If you take this equation, I have taken this equation and find out the value of 2t, no? If you take this equation, you will also get the same value of m2. Let's try it out. Okay,